On a seesaw, is it possible for something really heavy to be balanced with something really light? In this video we're going to be exploring that question by looking at something called turning moments. Imagine this situation. The black line here could be a meter rule and it could be suspended on a pivot. Now, pivot is just a point that the ruler is allowed to rotate around, so it's something like a seesaw. Now we've got a weight of 10 newtons here pushing down this way. We've got a weight of 50 newtons here pushing down on this side. Now intuitively we know that this is not balanced. We know that the ruler would rotate in a clockwise direction. From a physics point of view though, how do we know that? For a force that's trying to rotate something, we use something called turning moment. The turning moment of that force that's trying to rotate something is equal to the value of the force measured in newtons multiplied by how far away from the pivot that force is. The technical term here is the perpendicular distance from the pivot, but for GCSE purposes we will just think of it as the distance from the pivot. Force is measured in newtons, the distance is measured in meters, that means turning moment is measured in Newton meters. Look at these two examples. In the first one we've got a meter ruler here, there's the pivot, there's a weight of 10 newtons and that weight is 0.5 meters away from that pivot. So if we wanted to calculate the turning moment we would simply use the equation there, turning moment equals force times distance from pivot, which in this case would equal the force which is 10 newtons multiplied by 0.5 meters, which would give us a turning moment of 5 Newton meters. Now what's important here is that we have to understand whether this turning moment is a clockwise one or an anti-clockwise one. Well, as you can see, this one's going to push down, so that's going to be clockwise. The second example gives an anti-clockwise turning moment. The weight is on this side, the pivot is over here, which means if this side falls down, that's going to rotate the ruler in an anti-clockwise direction. We still calculate the turning moment in the same way, but it's important to remember that it is anti-clockwise. Well, turning moment is force times distance. Well, we know that the force in this case is 40 newtons. The distance from the pivot is 0.4 meters. That's going to give us an answer of 16 Newton meters in the anti-clockwise direction. There's a very important rule that uses turning moments. It says that if something is balanced, the clockwise turning moment must equal the anti-clockwise turning moment. Notice it doesn't say that the force on the left hand side of the pivot has to equal the force on the right hand side of the pivot. Not at all. It says that the turning moment that tries to make it go clockwise must be equal to the turning moment that tries to make it go anti-clockwise. Let's apply this rule. In this example, on the right hand side we've got a force of 50 newtons of a distance of 0.5 meters. This is the clockwise turning moment. So let's calculate what that is. It's the force times the distance, so it's going to be 50 newtons multiplied by 0.5. 50 times 0.5 gives us 25 Newton meters. The clockwise turning moment is 25 Newton meters. Let's try the anti-clockwise turning moment. Over here we've got a force of 10 newtons and the force of 10 newtons is 0.5 meters away, so the anti-clockwise turning moment is going to equal 10 times 0.5 and that is going to give us 5 Newton meters. Now we can see quite clearly that the clockwise turning moment here is 25, the anti-clockwise turning moment is only 5, therefore this will not balance, it will rotate in the clockwise direction. Now look at this example. Here we've got a heavy weight of 20 newtons, which is 0.2 meters away from the pivot. Then we've got a 5 Newton weight, so a much smaller weight, which is 0.8 meters away from the pivot. The question we need to ask ourselves is, will it be able to balance? Well, let's work out the turning moment. Starting off with the anti-clockwise turning moment, we need to get our force, which is 20 newtons, and multiply that by the distance, which is 0.2 meters. Well, 20 times 0.2 comes out at 4 Newton meters. So the anti-clockwise turning moment caused by this weight is 4 Newton meters. Now let's try the clockwise turning moment and see what we get. Well, it also equals the force times the distance. This time it's a 5 Newton force multiplied by 0.8 meters, and that is also 4 Newton meters. So in this case, it will be balanced. A 20 Newton weight can balance a 5 Newton weight as long as the turning moments are identical. That's it for turning moments. If you have any questions, please feel free to leave them in the comments below. Also, please check out the other videos that cover most topics in GCSE physics, and also please do consider subscribing to Physics with Mr. Drew.